Hello, good morning, everybody. Can hear me? Hope you can hear me. And then this is the discussion class. 15 minutes earlier, the class starts from the previous lecture we are going to discuss here. Still, we have 15 minutes to go to start today's class at 9:30. So, from the previous discussion, from previous lecture, I'd like to see the practice problem that what I have given based on the current division, voltage division. And if you can see this problem, the screen, the current division, some of you are having problem with this. That just I'm going to let you know that how to solve this problem. If you can be with me online, should be fine. Now, what you have to do in this current division rule first, first problem you have to do that you have to find the value of Ix equal to what uh, if the I1 current is 12 milliampere. This is the first question. Now you look, where is Ix? Ix in this circuit is over here. Ix equal to what? If I1 equal to, where is I1? I1 is here. You can see I1 is flowing through this, and that is flowing through this, that is flowing through this. So your I1 is given here is a 12 milliampere. If I1, so it is the I1 current flowing through this and enter into this parallel circuit, which is where the current I1 is going to be divided into two parts. One part is this, another part is this, and this part is Ix, and that what Ix you have to find. Now, if you think like this, you can also can imagine like this, that the current is dividing into two parts. That is, I1 is coming into two. One is this, one is that. So it is coming like that. So what happened? This one as a R1, R2. If you want to find I1, this is Ix as a part of that. This is what the 15 ohm resistor. You can imagine this is a 15 ohm resistor, and this is the 15 ohm, and this one is what 30 ohm resistor. So 30 ohm, 50 ohm resistor I1. This is your I1, and this is your Ix. Now, if I say according to the current division rule, what is Ix equal to? Then you should tell me that Ix equal to the total current. Total current is I1 entering into the circuit. Total current is I1 divided by summation of the two resistors, that is 15 plus 30 into what? Into the opposite resistor. What is the opposite resistor? Ix, you are going to find opposite resistor is 15. So 15 will be the opposite resistor. So the equation will be this. So that is what we are going to write over here. That the Is equation is here. The total current is I1. Total current is I1. I1 is entering through this in this network, and divided by summation of two resistors. Two resistor is what? One is R1, one is R2. R1 plus R2, which is 30 plus 15, or 15 plus 30, whatever you write. So 15 plus 30, you can see, into opposite resistor, which is opposite resistor is 15. So it is 15 ohm. So if you go with this, then the equation comes like that. That final equation is coming like Ix equal to, what is the final equation coming then? Then it is coming that Ix equal to, this is means this is equal to Ix, right? This is what I'm talking about. So this is the equation. You can have the equation for this. Now, if you want to find the Ix equal to what, then what will be the value coming here? You also substitute, because the value of I1 is given as what? I was given here as 12 milliampere. So I1 is 12 milliampere, and this is 45, and this is 15, and you are getting the value equal to what is the answer coming there? It's coming here, the 4 milliampere. So your answer here, Ix is 4 milliampere. So your answer here, Ix is 4 milliampere. So this is the answer to the first problem. Then we go to the second one. Second one is very much similar. Here you have to find the value of I1, not Ix, like other way around. You have to do it opposite thing. That is, in this case, you are going to find the value of I1 equal to what? I1 equal to what? If you can find I1 equal to what? Last time Ix equal to what? Oh, this is I1 equal to what? So, okay, this you can see this last problem we have found Ix equal to what if this. Now we have to find I1 equal to what if Ix is 12 milliampere. If Ix is 12 milliampere, then what is I1? So what you do, you will use it is the relationship between I1 and Ix. So you should use the same equation which giving the relationship between Ix and I1. Now for the second problem, what you have to do, I'm going to wipe out this part. So the second problem, for that you use the same equation, but in this case you have to substitute the value of Ix. In this equation, Ix is given here 12 milliampere. So you have to put 12 milliampere equal to I1 is, you have to determine, and this is 45 and this is 15. Same equation. This time Ix is given, so you substitute the Ix value. Last time I1 was given, so you substitute the X value. So that's the only difference, nothing else. So your I1 is, if you find from here, then it is cutting off as a 3 times and then 3 times 36. So 36 milliampere you're getting. So your I1 answer is coming here as 36 milliampere. So it is very much straightforward and very simple. So you can get the answer for number B and number A as a 4 milliampere and 36 milliampere. It's very straightforward, you can get. Now let's go for the question number C, where you see the question is given Ix equal to what? You have to find the value of Ix again, but this time not I1. In this time, question C, it is given I2 equal to 15 milliampere. Then what happened if I2 is 15 milliampere, then what is the value of Ix? And this time you have to find the value of Ix also, but in this case I2 is given, not I1. So in this case, if you want to see the circuit in a bigger way, I'm going to wipe out the previous solution. Now I think all of you understand it. Now let's and this equation is valid, so this equation is okay, standard. Now we have given the value I2 is given here. This is I2, which is given 15 milliampere. And what you have to do is Ix you have to find. What is the value of Ix? That one, this one. So if you want to find Ix value, what you need the value of I1. So I1 will be coming from here, and that if you get the value of I1, you can easily find the value of Ix. That is what asking for. But I1 you have to find from where? That you are going to substitute the value of I1, but you need to find the I1 value first, and then you can substitute it into this equation. You get the value of Ix. The question is, how can you find the value of I1? Let us go with that. Now look at it with the thing here. Now if you look at it, the current coming from this circuit, the main current coming here, which is let's say Is current is coming through that, and Is is coming through that, and divide into two part. One part is dividing into, one is current is coming this way, another current is going through that way. You can understand at this node, the current is going to divide into two parts. One is going that way, one is going this way. So that way current is your I1 current, and this way current is your I2 current, right? I2 current. So this total Is is dividing into two parts. One is I1, I. Now I1 is going through this resistor. If you see the whole bunch of resistor here, and if you see the other part of the resistor here, I2 is going through this resistor, I1 is going through that resistor. So this big resistor is what? In this case, let's say this is R1, and R1 will be what? And let's say this one is R2. This one is R2. R2 equal to what? Any children can understand. R2 is nothing but this 5 ohm and this 25 are in series. So 5 plus 25, you are getting 30 ampere, 30 ohm. Okay, I'm writing it here like this, that is a 5 plus 25 is giving you 30 ohm. So R2 is 30 ohm, and R1 is what? R1 is 10 ohm is series with 15 and 30. So you can write R2, R1 will be nothing but 10 plus 15 parallel 30. So 15 parallel 30 is giving you what? If you look at it, the R2, 15 parallel 30, if you look, then you are getting the resistance equal to, what is the thing coming? Is it 20 ohm? So it's a 20 ohm is coming here, and this 20 ohm is going to be added here. So as a R1, and that one is R2. So your total IS current is dividing into two current. One is I1 and R2. Like this guy, what will be the I1 in that case? That means your, just I'm going to show you like this. You just imagine. That means IS is coming through this, and one current is R1 and another current is I2, R2. This is R1 as a coming like this. Imagine like that. So this is your I1, this is your I2, and this is your I2 means this is your 30 ohm, and this is your 20 ohm, 20 ohm, or you can say 20 ohm. So 20 ohm resistor and third. So in that case, current division rule, if you apply, then automatically you can tell me this, the I is nothing but what? I is nothing but I1. I1 is nothing but IS divided by total resistance, summation of the two resistance into opposite resistance. What is the opposite? 30, R2. So R2 is 30 means, 30 means here is 30. And that is the equation you are getting I1. The current division rule gives you I1 equal to this. Now, if you replace the I1 as I1 here, equal to IS, if you write, IS is what? IS, you can write, since IS is not given, so you can write IS means I1 plus I2. You can replace it by this. And 30 plus 20 is a 50, and this is 30. So you can easily finalize it. What is the value coming there? 30, 50, 50, 0, cancel, 3 is coming there. So you are getting here 5I1, if it was multiply, 5I1 equal to 3I1, 3I1 and 3I2, 3 into I2. Now what is I2 value? I2 value is given here, as I2 value is given 15 milliampere. As you can see here, it is 15 milliampere. So I2 value, you put there 15 milliampere. So 3 into 15, if you write, then you are getting the result now as what? Is a 5 and 2, 3, I means 2I1 minus equal to 30. That means you are getting, it is equal to what? I1 is, what is the value of I1 coming there? If we calculate it, 3 times 2, is it 5I2, 2, and 3I2. So it is giving you what? I1 equal to 15, right? It is I1 equal to 15. So 30, 45, not 30. So 43 into 45. So I made a mistake here. Okay, so 45 here, 45. So I1 equal to what in that case? I1 equal to 22.5, 22.5 milliamps you can write. Okay, so this is the I1 value you got. As I said that to find the value of Ix, our target is to find the value of Ix, right? Our target is to find the value of Ix. So if you want to find the value of Ix, then here we have to substitute the value I1 equal to what? So I1, if you put, which is 22.5. So 22.5 milliamps divided by 45 into 15, the previous formula, and you're going to get this is 7.5 milliamps. So your answer here is 7.5 milliamps. Your Ix here is 7.5 milliamps. This is the way you can find the solution for the question number C. And question number D is the same question. You can see you have to find the same thing. What is that? Ix equal to what? If Is is 600 given, if Is is 60 milliampere given here. So if you go Ix equal to what? So the same thing, Ix equal to what? Same question, same equation you have to use. Ix equal to what? That means you have to find the value of I1. I1 now in this case is not 22. In this case, I1 is what? We have to find it. Now again, in if you go the same way, then the equation here, I1 is, we have written the equation here. Look at it. The equation we have written already. I1 equal to this Is. So you don't need to go there. All you can do into this from this equation, you can write it that I1 is equal to, because it is given directly the Is value. So you can straight away, you can straight away go for it. So you can write it that I1 is equal to, okay, I1 equal to what? Then you can find I1 equal to Is divided by, so Is is what? Is is given here as I1 equal to, Is is given here as 60. You can see Is value is 60. So you can put 60 here divided by 20 plus 30 is a 50. It is 50, you know that it is 50. So what I go for is 50 divided by 60 by 50 into a 30. 60 by 50 into 30 means what? Now you can easily get the answer from here. The value is coming as, what is the value coming? The 50, 60 cancel out, then 1800 divided by 5. 36 milliampere you are getting. So if you get 36 milliampere, you can substitute I1 value as 36 milliampere into this equation. So it is no more 22.1, it is 36 milliampere, 36 milliampere. So the new value comes, because this is cancel out, to new value comes is a 3, 15, 3 and 36 cancel out, 12. So you are getting, what you are getting here is 12 milliampere. So ultimately you are getting the answer is 12 milliampere. Let us see what is the, oops. I'm sorry, just a minute. Okay, the answer is 12 milliampere Ix if you get for 660. So 12 milliampere is the answer for this case, and I'm writing here Ix is here 12 milliampere. So these are the answer to the question. Now in the last next slide, you can see which already is solved in the, which is also shown here as you were seen last time, is the same thing. So this is the way we can get the answer that Ix first question, Ix is 4 milliampere, I1 is 36, Ix is 7.5, and Ix here is a 12 milliampere. So it's all okay. This is for the previous, from previous class. So our time's up. Now we are going to jump to the next class, as well as today's class, which will be based on the node analysis thing. So we are going to go for it. So I hope that we can start the class now. Thank you very much. If you have any question or anything, you can note it down, and next class, before next class, 15 minutes earlier, we can discuss it. Now we are jumping to our next class. Thank you very much. Okay, we can start our class today. This is only 9:30. So the topic today we are going to talk about is a node analysis and supernode. So finish the node analysis, can have time, then we can go with the supernode after that. Now, we already know about what is KCL and what is KVL. So that we now the KCL is your Kirchhoff's current law, and KVL is Kirchhoff's voltage law. And the application of this KCL KVL we can see over here in this node analysis and mesh analysis. For node analysis, we need the KCL, Kirchhoff's current law, and for mesh analysis, we need the KVL. So today we are going to see the node analysis and the application of the KCL over here. And next class, we will see the mesh analysis later. Now, if you go with the node analysis, then we can see here, node analysis says that an n node circuit will have n minus 1 unknown voltages and n minus 1 equations it provides. That means in a circuit, if we ask you how many nodes are there, you can easily tell me, and that is the n number of nodes over there. That means in last class earlier we have seen that what is nodes and what is a branch, and how to find the, and what is path and what is closed path, closed loop. These things we have seen. Now, what is node and how many nodes in a circuit? By looking at the circuit, you told me in the last class we have seen. Now, likewise, if I ask you, can you tell me how many circuits, how many nodes are there in this circuit? If you go with that very easily, you can say there are 3 nodes on the circuit. One node is here, another node is here, and another node is here. These are the 3 nodes over here. This is node 2, and this is node 3. So 3 nodes are there, means that's a total 3 node. That means the number n is 3 in that circuit. That is, an 3 node circuit will have how many unknown voltage? N minus 1. That is 3 minus 1 equal to 2. That means 2 unknown voltage. A 3 node circuit will have 2 unknown voltage. 2 unknown voltage. Now, if you go to that circuit again, and then what are the 2 unknown voltages? You look, 3 minus, there are 2 unknown voltages. One is this one, the V1 voltage here. Another one is a V2 voltage here. These are the 2 unknown voltages. N minus 1 is a 2 unknown voltages here. Now, what is the third node? This node is the reference node. Minus 1 means this is the reference node. That is the ground. So this is number 3. That means we have in our circuit, this reference node is this one, this 3. Node 3 is the reference node. We can say this is the ground. So this is your reference node. In the circuit, this circuit actually can be converted into that, this circuit, that, this. All these circuits are same. This is A, B, C, D. All these 4 circuits are same, but in different way it is represented. Now, this reference node is number 3 node, which is minus 1, and that's why beyond V2, 2 unknown voltage. 2 unknown voltages are called 2 node voltages, V1 and V2. Now, our target is to find these 2 node voltages. So if here we can see there are 2 unknown, one V1, another one V2. And the third node, the ground node, is the reference node, so we don't need to worry about that. That means V1 should be with respect to ground, V2 should be with respect to ground. You have to find these 2 voltages. So 2 voltages, V1 and V2, you have to find from here. Hey, you know that if you want to find 2 unknown, you need minimum 2 equation. So that is what we can see here. N minus 1 equations are required for this 2 unknown. N minus 1 means 3 minus 1 again is a 2. So two equations are required to find these two unknown voltages. What are the two unknown voltages? V1 and V2. As we see the next circuit, V1 and V2, these are the two unknown voltages, and for that you need two equations, n minus 1 plus. The two simultaneous equation can give you these two unknown voltages, and that what now we can find it from the node analysis, where the node analysis should be applied in the node. And what you should apply for node analysis? The KCL. The KCL you have to apply at the node, and these two node, actually node 1 and node 2, you have to apply the KCL. So node 1 is this one, so you apply the KCL here. This is your node 1, so you have to apply at KCL1 at node 1, KCL1. Now in this node, if you want to apply the KCL, how many currents are involved? And you can just go ahead to do this thing. This is the current coming in, because the source current I is coming in, so you cannot change this current. Source current is entering into the node. The source current is entering into the node, so you have to draw the source current I in this way, and that current is 3 ampere. Let's say this is I1. We are defining this one as I1, and any arbitrary current, we can say that this current is going out, which is I2 can be said, and this current is going out also, you can say. Then this one will be also, this thing is I3 can be said, and then this current also can be out. You can say this is I4, you can say this is I4. Then this current can be said, and this current is out. So from the current source direction, this current must be out, and which can be right as a I5. So if it is, if these are the currents, you remember the current source current I1 and I5, you cannot change the direction. You should follow the current source direction. Source direction is upward and downward. You have to follow that. And other current direction, I2, I3, and I4, arbitrarily you can do. And whenever you find the answer for I3, I2, I4, and then you can see the I2 answer or I4 answer can be negative. If it is negative, then the direction will be opposite. You have to understand. It is what I told you earlier. So you don't need to worry about the I1, I2, I3 direction. Arbitrary direction can be considered here. Now, if you apply the KCL1, and how many current in this node, if we ask you how many currents are in node 1, there are 3 currents. One is your I1, and I1 is coming in, so it is positive. I2 is going out, so it is negative, and I3 is going out, so it is also negative, and equal to 0. This should be your KCL1, I1 minus I2 minus I3, because I1 is coming into the node, and I1 is coming into the node, I2 and I3 is going outside the node, is going out from the node, and that's why those are negative. So equal to, I think you understand that part. Now if we write the equation for this gut, then we can see that I1 is what? I1 is 3.1, and I2 is what? I2 is the, yeah, some of you asked me question, what is that?
Sir, so here the current across the resistor is 3.1, and this is the voltage for the first node V1. So the voltage is will be same, I think, if
Okay.
we apply the
No, I'm
uh,
going to draw it again, then you can understand it clearly. Look, this is the current source, this is the resistor, this is another resistor here, and this is the current source, right? This is the
yes, sir.
thing, and this one was 3.1 amps, 2 ohm. This is V1, V2, and what was this value resistor here? 3 ohm, is it?
5, sir.
This is 5, and then 5, and that one
minus
is other one is 1 ohm, right? And this is 1.4. Okay,
1.
this is 5, this is 1 ohm, and this is minus 1.4 amps. Okay, now I'm talking about, listen, it's okay. I'm talking about what is the voltage. This current I consider as a I1. This current is this is current I1. This is I2. I'm talking about I2, right? And this current I said I3, and assume this current is I4. My and this one is incoming, so it must be I5 incoming. So this I1 and I must be incoming. That's all, because the current source direction is given. But I2, I3, I4 arbitrarily you can consider. But if your answer is, if your direction is not correct, answer will come negative. I told you in the KCL time. You know that. Now listen. I'm talking about what is the voltage across the 2 ohm resistor. The voltage across 2 ohm resistor is V1. So this is plus and this is minus. This is the voltage V1 across the 2 ohm resistor. Do you understand that? If you got it, what is the voltage across 1 ohm resistor? Can you tell me?
Uh, Current will be
And I'm
3.1
asking you
ampere.
which voltage. Voltage. What is the voltage?
V2,
Yeah,
sir.
right. This is straightforward.
V2.
It is V2. V2 means this is plus. Okay, this is plus. This is minus, and this will be V2. This why everybody should try to understand what does it mean. It means this point, node point, the voltage node V1 means if you connect a voltmeter, this is a ground. If you connect a voltmeter in the lab, when you do the lab work, as an electrical engineer, every children should know it, understand it, otherwise you cannot. Okay, you connect the voltmeter, one point here, another point here to the ground. This is the voltmeter. I'm talking about the voltmeter. At one point you connect here, another point you connect here. Voltmeter got two terminal. These two terminal, if you connect across these 2 points with respect to ground to this point, then voltmeter reading will be what? The voltmeter reading will be V1. Got it?
Yes, sir.
Yes,
Except,
sir.
yeah, same thing happening here. If the voltmeter you connect with respect to ground, here the voltmeter, you have you heard the name voltmeter in your life, or this is the first time you are hearing?
Yes, sir. Here.
Okay, you heard it before. So that voltmeter, if you connect here, this will give you the voltage V2, which is the voltage across 1 ohm resistor. Now you clear?
Yes, sir.
Okay. If I ask you what is the voltage across 3.1 ampere current source, it is also the same. It's the same point. That means if you connect a voltmeter here and measure the voltage across this current source, it will be also V1, because this is the same point. This is also V1. So it will be also giving you V1. That means the voltage across the current source also V1. Okay?
Yes, sir.
And what is this voltage source? What is the voltage across this current source? Tell me.
Sir, V2.
V2. That's it. So this is what happened. Now if I ask you what is the voltage across, if that connects the voltmeter here across the 5 ohm resistor, what is the voltage across 5 ohm? If the current flow direction I3 is this way. Oh, you all are dumb. Look, if this is a resistor, if this is V1, if this is 5 volt, if this is 2 volt, and I ask you what is the voltage between this across this R, what do you tell me?
Sir, V1 minus V2.
What is the value?
3 volt.
3 volt. 5 minus 2. You said 5 minus 2 because current is flowing this way, high potential, like this way. If the current is this way, then this is 5 minus 2 because higher potential to lower potential. What happened to the 5 ohm here? What is this voltage?
Sir, V1 minus V2, sir.
Why you did not say V2 minus V1? Why you say V1 minus V2? Can you tell me? You're right, but
Sir,
tell me.
sir, because the first voltage current flows from the
Yes,
positive
absolutely good. Because the current I3 is flowing from V1 to V2. From V1 to V2 direction means V1 will be greater than V2, we are assuming in this case. That's why the voltage reading will be V1 minus V2. That's the voltage across 5 ohm resistor is V1 minus V2. Everybody understood?
Yes, sir.
Because
Yes, sir.
this is the first problem, and this is a very conceptual problem. I'm explaining in details here so that everybody understand. Next problem onward, I'm not going to talk in details like that. So everybody please try to uh, answer me if you cannot understand. Tell me, sir, here I cannot understand. The first problem, everybody may have some problem. Okay, if this is the scenario, then I2 will be what? Okay, I'm going to that one. I2 will be what? Look at it. I2 is this one. All of you look, this green line I'm drawing. Green line. Green line is 2 ohm resistor. I2 is the current flow. Voltage across the 2 ohm resistor is V1. Ohm's law say I2 equal to what?
Sir, V1 by 2.
V1
Absolutely.
by V1 by
V1
two.
by 2. This is Ohm's law. These are the basic thing. You should know that. So your I2 here, same thing, V1 by 2. V1 by 2. Now you tell me, you have any confusion or you understand? Tell me please faster. So I2 means here we are writing V1 by 2. Anybody got
So we
confused?
just put the value here, just
Yeah,
nothing
that's,
else.
yeah, we are going to substitute the value of I2 here. I2 means V1 divided by 2 is the resistance. We got it. Got it now? You can understand it now. If I put I3, I3
Yes.
equal to what? What do you think I3 equal to what? Okay, look at the diagram there in the next page. I3 is this one, right? This is I3. Look at the green point. I3 is the current through what? Through the 5 ohm resistor. What is the voltage across the 5 ohm resistor? As we all decided, it is V1 minus V2 is
V1 minus
V2.
V2.
right. If it is the all these three green circle, I3 is the current flow through 5 ohm resistor. The voltage across 5 ohm resistor is V1 minus V2. So if you apply Ohm's law, I3 will be what?
V1 minus V2 by 5.
V1 minus V2 by 5. Everybody should understand it, remember, otherwise you'll be in trouble next. Okay, good. So slowly you'll see it's very simple for you. Okay, V1 minus V2 divided by 5. This is what? Equal to 0. That's your equation number 1. KCL equation number 1 is this one, where you can see the two unknown variable is there. One is V1, another one is V2. Okay, sir, cannot see the thing, right? Okay, now can see. Hey, is it okay now?
Yes, sir.
Okay, anybody got question? Cannot
Sir,
understand?
this is
Go.
sir. This is for the first node actually.
Absolutely, and that's what I'm talking about. This is the KCL 1, and for the second
Yes.
node, KCL 2 gives you another equation. These are the two equations, and you have to solve these two equations for two unknown. What are the unknown? Unknown is V1 and V2. Hey, can you solve V1, V2 from this one equation?
No,
No,
sir.
sir.
Excellent. That's why you need another equation, and that comes from the second node. Second node is this one. Second node gives you KCL 2. So you can see KCL 2 here. If you apply the KCL 2 here, then what you get?
Sir, sir, can you
Yeah,
please go for the next slide because
yeah.
it is so much complex. That's why it is hard for us to
Okay, if
understand.
you go to the next slide, is
Yes, sir.
this one.
Yes.
I'm going to show both slides so that you can understand it much more better. I'm just, before going to these, I'm just going to show you here first, then we'll go to that slide and then compare. Okay, now look, in this case, uh, this is the current. Look at it. In this case, what is the current coming through this? What is the current in this case? Three currents. What are the three currents in this case? Can you tell me? In node 2, which are the currents? I3, I4, and I5, isn't it?
Yes, sir.
Can you see I3, I4, I5? Are you very old man that cannot see? What is this? This is the current I3. This is the current I4. This is the current I5, right?
Yes, sir.
Yes, sir.
Now, these currents, you tell me now, I'm taking it off. Now, you tell me these currents. What are the current? I3. I3 is what? Incoming or outgoing?
Incoming current, sir.
Incoming. Incoming means plus. So I can write
Plus.
here. Yeah, I can write here plus I3. And I4 is what? Outgoing, incoming?
Outgoing. Outgoing.
Outgoing, I4. So it will be minus I4. And I5?
Outgoing.
Outgoing. So it is I5 is outgoing. That's fine, no problem. Now you go for the substitute the value. I3 is what? Hey, what is I3 supposed to be? Can you tell me, anybody?
So
Same.
I3
Good. Same. What do you
V1 minus
V1
V2 by
minus
5.
V2 divided by
Beautiful, beautiful. This is your I3. We already found I3 equal to this guy. I3 is already, we found V1 minus V2 divided by 5. Excellent. So you should write simply here V1 minus V2 divided by 5. V1 minus V2 divided by 5 minus I4. I4 is what? Same way. I4 is what? Anybody can tell me I4?
V2 by 2.
Absolutely correct.
V2 by 1, sir.
V2 by 1, not 2, because it's a 1 ohm resistor. Yeah, you are right.
Yes, sir.
V2
I
by
can see,
1. You can easily understand now. Minus I5. Hey, what is I5?
I5
V2 divided by minus 1.4. Is it?
No, sir.
Then what is
No,
the
sir.
I? That is what is I5? Bit faster.
Sir, just minus 1.4.
Minus 1.4. So you should write minus 1.4.
the plus.
Yeah, it will be automatically plus. So this is the equation coming here. And this equation, if you simplify, then you can get it. This is equation number 2. So these are the two equations we are getting from this 2 KCL. All of you get it?
Yes, sir.
Yes, sir.
So I think, do you want me to go to the next slide and show it again, or you think you understand? It's a very simple job
Sorry.
now, right? All of you understand it. This is your I3, this is I4, this is I3, and then this is these are the three currents, and you have seen these three currents addition, and then V1 minus V2 divided by 2. I3 is this, I2 is what? I4 equal to what? I4 equal to V2 divided by 1 is I4. So V2 divided by 1. You all understand it. So we better jump to the next slide and we can write the equation. Hey, now I'm asking you, have you written the equation number 1 and equation number 2 on your paper?
Yes, sir.
Okay, now you
Yes,
follow.
sir.
Yeah, you tell me what are the equation. Tell me equation number 1. Can you bit faster?
3.1 minus V1 by 2
3.1 minus V1 by 2
minus V1
V2
minus V1 minus V2 by
Divided by
5.
5 equal to 0 is equation 1. And what is the equation 2?
Sir, V1 minus V2
divided by 5
by 5
minus
V2
by 1 minus or plus 1.4.
plus
Okay, this is equation 2.
1.4.
Now, can all of you solve the problem and tell me what is the answer? Because you need to know how to solve the problem. Just, you know, there's two equation how to solve. You try first and tell me. Anybody done it already? You have to do it. This is very important for you to asking me the question you are having problem. This is very important. But if you see the lecture note, you have question, you cannot ask me at that time. This is your problem. That's why I'm telling to come to the class and you ask me question, clarify the thing. It's a much better for you to understand. Okay, good. I think thank you very much for asking this question. Now, in this case, if you go the KCL one, how many currents there? Altogether 4 currents, and the 4 currents will be like this. I1 is coming in I2 is coming in, so I2 also plus. Please, anybody got any question like him, ask me immediately, then we can solve it. Thank you very much for asking this question, because otherwise you will be confused. I3 going out, I4 going out, there's a 4 current. That's it. This is your ICL, KCL1. Now I1 is what? I1 is straight away minus 8. If you cannot get me, tell me. And I2 is what? I2 is plus, it is minus 3. Okay, if you cannot get my point, you cannot get it, please tell me. The way I'm telling, maybe I can explain it more clearly. Okay, this is minus 3. Okay, and then your, what is the next one? Minus I3. I3 is what? I3 will be the current flow through 3 ohm resistor. 3 ohm resistor. Current is I3. Current is I3. What is the voltage across 3 ohm resistor? Anybody can tell me?
Sir, V1 minus V2.
Beautiful. Excellent. This is V1 minus V2 divided by I3, means this is 3 ohm resistor, 3. Good. Now I4 minus I4. I4 equal to what? I4 is, okay, I4 is the current flow through 4 ohm resistor. One point is here, another point is here. I4. Okay, so the current is I4, voltage is current is I4, resistance is 4. What is the voltage across 4 ohm resistor? Anybody?
Sir, V1 minus
V1
V3.
minus V3.
V1 minus V3. Beautiful. Now you understand it. V1 minus V3 divided by 4. V1 minus V3 divided by 4 equal to 0. This is the equation for the KCL1. I think, yeah, first KCL. You all understand it now?
Yes, sir.
Yes,
Good.
sir.
Okay, please copy it down. Otherwise, I may erase it. So this is first one. Now go for the second one. And second one, KCL, this one, if I write, all of you should understand it. From here, I'm going to do. Now, this is, I'm writing here, KCL2. KCL2 is going to give you like this way. I3, I'm writing here, I3 is in minus I2, I3 minus I2. This is I2 is going like that. I2 is this direction. I3 is there. I4 is, this is I1. All of you got it actually. I4, I3 is just a little movement of the slide. Okay. Now, any question can ask. I3 minus I2, then minus I5, then minus I6 equal to 0. How many altogether? There are 4 current in node 2, right? Yes, and those 4 currents are I3, I2, I5 and I6. Any question or it's all right?
That's all right.
Okay, we are going to cut the Zoom soon and rejoin please. Okay, now let's come back to the point. If this is the scenario, then I'm writing the equation. Equation is I3 will be exactly the same way. V1, I3 equation you already got. V1 minus V2 divided by 3. I3 means this is the current I3. I2 means this is the current going out. Just try to get my point. Okay, now I2 is minus, I2 minus, minus 3. Minus, minus 3. Okay, and I5, minus I5 means, minus I5 means V2, what? V2 divided by?
1.
1. Excellent. That's all right. And then I6, minus I6 means, what is I6 means? I6 means
Sir,
this 7.
V1 minus V3 by 7.
V1 minus V3 by 7.
V1 minus V3.
For
Sir,
the
V2 minus V3, sir.
V2 minus V3, sir.
Right. V2 minus
sorry.
V2 minus V3 divided by 7. And that's equal to 0. So this is equation number 2. Equation 1, equation 2, equation 1, equation 2, and another equation 3 if you can find correctly, you get the maximum marks. You get the hands-up marks. In engineering, this is very important. After that, you find solution, Cramer's rule, or you can use the programmable calculator and learn how to use the programmable calculator to solve the three unknown problem, three unknown equations solution. Now, third equation will come from from this node, from this KCL. So this KCL will be what? Now question is what? Now, hey, listen, do you understand? I'm going to
Yes,
wipe
sir.
out, yeah, I'm going to wipe out the KCL one. So I hope that you have already copied. So I'm going to write the KCL 3 over here. Okay, I think should be fine. Now look at it, KCL 3. How many currents are involved? Anybody can tell me? KCL.
I6.
How
Sorry,
many?
I.
How many? How many? 1, 2, 3, 4, 5,
The
6. How many?
Three,
Sorry?
sir.
three. Sir, three.
No,
Three
not
current.
3. Anybody? Is it 3? 3 current. One current is here. One current is going out. One current is coming in. And
4 currents,
another
sir.
current. Then how
The
come?
four.
3? Yes, sir. This is a mistake. Careful. Okay, now what are the currents? Tell me, what are the currents? I1, I2, I3,
I.
I4.
No, sir.
I5, I6,
I6,
I8, I7.
I5.
No,
I7.
I5 is not involved here. I5 is a different current through 1 ohm resistor. Not I5. Tell me, what are that?
Sir, I3.
I3.
I3
I3 is
I6.
not correct. I3 is also
Sir,
not correct.
I4,
I6,
I6.
I4, I7, I8.
I4, I6, I7, I8. Good. So
I6.
if you say I4, I4 is in or out?
In, sir.
In. So it is positive, I4. Then you said I6. I6 is in or out? Bit faster.
In, sir. In.
In. I6 is in. Everybody check. And I7, in or out? I7.
Out.
Out. I7 out.
Sir,
And
sir, can you please
I8,
clarify this one?
Out, sir.
let's
Out.
out I8. Yeah, what do you want me to verify? Anyone say
Sir,
verify what? What verify?
sir, no, clarify, sir.
Oh, clarify. Okay.
Sir,
Huh. I4 is this one. This is the, look at this. This is I4 current going through this. This is I4, right? Do you
yes,
understand
sir.
I4? Okay, I4 is coming into the red circle. The red circle is the node. Okay, I4 is coming into the red circle. Okay, then this is what? What
Yes,
is this current?
Yes, sir.
Okay, good. Now look at this. These are the things. Now I8 is going out, so minus L. Now I4, what is I4? I4 is again same what we have written I4 equal to last time. So
So
what are
I4,
I1?
I6.
No, I4 means what?
Sir, V1 minus V3 by
Outgoing.
4.
Right.
In
V1. No. V1 minus what?
V3.
V3. V1 minus V3 divided by
4.
4. This is your I4. Look at it. I4 is the current, 4 is the resistance, and voltage is V1 minus V2. V1 minus V3. Try to get me I4. I have written earlier. This I4 equation, last equation, I can see the first equation. Okay, and that is the same thing. Plus I6. I6 is what? I6 is
V2 minus V3 by 7.
by 7. V2 minus V3 by 7. V2 minus V3 by 7. And I7 minus I7 is what? I7
Minus
is
25.
minus 25. So minus 25. Okay, then next, then minus I8. I8 is what?
V3 by 5.
Right, V3 by 5. Now you all understand it. Very simple. V3 by 5 equal to 0. This is equation number 3. These are the 3 equations. If you can understand and you can find it, you get maximum marks. And next step is, after solving these 3 equations, you have to find the value of V1 equal to what, V2 equal to what, and V3 equal to what. These 3 simultaneous equation. So everybody must learn how to find the 3. This is very hard. It is the question you can expect in the class test. So all of you need to know how to find the solution of these 3 unknown, V1, V2, V3. You can see in the books how to do, or you can discuss with your friends using the Cramer's rule. And most important thing you need to understand, these 3 equations, linear equations you have to find, and these 3 equations you have to enter into the programmable calculator, and in one shot you can get the answer. This is very important. I'm telling you again, all of you must learn this thing, please. I'm writing here, must learn these things, how to find the, let's say I'm getting you, let's look at it, the equation. Let's say the equation you got from something like that. Just don't, this is the one, I'm just going to assume this is the one you get. Then equation number 1 gives you like that. For example, those are, I got different equation. Come on, man, this is not the correct one. I'm just arbitrarily, I am writing here. So you must not get this answer. It should be different. I'm just telling you, example, 7v1 minus 2v2 plus 3v3. Hey, equal to 10, equal to 5, equal to is a 30. Let's say these three equations simplify. If you simplify, you get the simplification form similar to this. This is similar, not like same thing, similar. After that, from here, you have to find the value of v1, v2, v3. All of you understand what I'm talking?
Yes, sir.
Yes, sir.
Don't think
Yes,
this
sir.
is the one you will get and you did not get it, so your answer is wrong. No, this is, I'm just telling you, assume. This is assumption. Assume. These are the three equations you get after solving. And then what you do, you have to find the value of v1, v2, v3 from this. How? Hey, Duck, how? That is what I'm asking you to learn using your programmable calculator or using Cramer's rule, finding the determinants, whatever way. I am asking, leaving it with you. This is your job to learn. If you really want to answer in the class test, I'm telling you again, please, 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 please. Otherwise, you cannot answer any question. You have to do this sort of calculation. And this three simultaneous equation solution, every time in the mesh analysis, you will see the same thing. In future, other method, you have to do the same thing. So everybody learn it now. Good. I think everybody understood it. Now, let us jump to this problem. Okay, here we go. I'm jumping it very fast. All of you should understand it. How many nodes here? Look. 1, 2, 3. And this is another one. 4. 4 is the reference node. Yeah, 4 is the ground reference node. So you have to find V1, V2, V3. Again, V1, V2, V3. I'm going fast. So now you see how easy to you to understand this. Actually, it is now very simple. I1 must follow the current source. So I2, I3 can be arbitrarily. I3, this is let's say I4. This is, let's say, I5 current. This is let's say I6. This is, let's say, I7. There are I7 we can consider here. Now, if I use the KCL1 here, KCL1, then it will be what? I1 is going out, so minus I1.
Minus.
Yeah, minus I1, minus I2,
Minus
minus
I2,
I3.
minus I3.
Equal to 0. So you can just write it like this. And then what will be I1 minus I1 is, oh, this one is, it is written, the ampere is not, no, the ampere value is a 7. This is 5 ampere. Or what is ampere? Have you seen? No.
No, sir.
Okay, just a minute. Can you see what is that? 3 ampere, right? It is 3 ampere. I'm sorry, I'm made it bigger and that's why it is gone away. Okay, it is 3 ampere. Or if you note it, just note it down.
Okay,
this is
sir.
it's 3 ampere. Yeah, 3 ampere. I'm talking about this is 3 ampere. 3 ampere current source. And this is 7 ampere current source. 7 ampere current source, 3 ampere current source. Okay, so minus I1 means minus 3. Minus 3. Minus I2 means V1 minus, now all of you understand it. So V1 minus V2 divided by
minus V2
1.
by
Minus
1.
I3 equal to what? Hey, V1 minus I3.
V1 minus V3.
Right, divided by,
V3.
come on, then divide by what?
2.
Divided by 2.
2.
Equal to 0. This is equation number 1. All of you understand it?
Yes, sir.
Everybody understood. Okay, good.
Yes, sir. Yes, sir.
Now KCL2. Now KCL2, KCL2, if you go, how many currents? 3 currents. One is your I2, I4, I5. So I2 is coming in. Okay, I2 is coming in.
I5 is coming in.
No, I2, yeah, I2 is coming in. I4 and I5 is coming in or out?
Sir, coming out.
Out.
Yeah, then why you are saying in? Equal to all are negative. Okay, got it? Now, what is I2 equal to? I2 equal to what? V1? Hey, can anybody tell me? V1 minus?
V1 minus V2 by 1.
1. Hey, any of you cannot understand, please immediately hold me and ask me the question. Please, you have the right to ask me to understand it. And then I4 equal to what? I4 equal to
I4 equal
V2
to
divided by what?
2 by 3.
Right.
Sir.
And then what is I5?
V2 minus V3 by 4.
4.
V2 minus V3 by 4 equal to 0. This is equation number 2. So equation number 1, equation number 2 you got. You need another equation because 3 unknown, V1, V2, V3. So another equation is KCL 3. Yes, any question, please? Somebody want to ask question? I'm going to delete the KCL 1. I'm going to write KCL 3 here. I think everybody copied. Yes or no?
Yes, sir. Yes, sir.
Okay, fine. Now let's come back to that one. This is the note 3 where we can write the KCL 3. If you write KCL 3, how many currents involved? Bit faster. How many currents?
Sir, 3 currents.
Oh, you kill yourself.
Four currents.
So what are you talking then? No, just hang on, hang
Oh,
on.
sorry, sir. Sir,
Okay, okay, now you can see, right?
yes, sir. What I3 also adds.
Okay, so yeah, that's right. So 4 current. Yeah, I3 is also coming into this. So 4 current means I5, I3. So let's say I3 add I5 also coming in. I6
I7 also
out, I7 is coming in. So
coming
you write plus.
in.
Yeah, that's so this is the thing. So you understand it. Now I3, what is
Yes, sir.
I3? Come on, Adam.
So I3 is V1 minus V3 by 2.
By 2. I5,
So I5 is V2 minus V3 by 4.
by 4. Good. And I6.
So I6 is V3 by 5.
V3 by 5. Good. V3 by 5. And then I7
I7 is minus 7.
minus. Why
Plus,
minus
plus
7?
7. Sorry.
Plus
Plus,
7.
plus 7. Sorry, sir.
Yes, sir. Plus 7, 0. This is equation number 3. So these are the 3 equations. If you can write, you get maximum marks. After that, I told you already, you have to get the formation like this. This will be simplified into this type of 3 equations after that, these 3 equations. And then you find the solution for V1, V2, V3 using how? How you have to learn it. How? Okay, using your programmable calculator or Cramer's rule, or I'm telling you again, please, please, please learn it how to do if you want to get full marks. Any question can ask me. Yeah, you can ask anybody, can show you these things, or your calculator you have to learn. Okay,
Sir,
good.
We can use the Kemmer's rules for the
Yes,
three
sir.
equations.
Anything you can do. You get the answer for V1, V2, V3 correct, you get full marks. But at least you can find 3 equations correctly, you get very good marks. But not full marks. You understand what I told?
Yes, sir.
Okay, good. Everybody should concentrate what I'm talking. Otherwise, all will be dumb. Okay, now you look at it. What to do here? If you look the question, you can understand it very clearly. What it means. Okay. In this question, this is the last question for node analysis, and then we'll jump to the super node on a bit faster. Here, again, what you have to do is same thing. You have to find the, in this case, it is said that you find the value of Ix. Ix is the current flow through 2 ohm resistor. And Ix will be what? Any children can, if I ask you what is Ix, using node analysis, you have to find it, Ix. So Ix will be what? The resistance is 2 ohm, current is Ix. What is the voltage? Hey, what is the
Sir,
voltage?
V1 minus V2.
So what is Ix will be? V1 minus V2 divided by
2.
2. And that value will be the thing you have to find. An answer given. What is the answer? Racket.
2.79.
2.79, right. This is what, now if you want to find the answer 2.7, what do you need to find? You need to find the value of what?
V1 and V2.
You understand? 2 is given already, 2 ohm. So V1 and V2, if you can find, then you can find the value of Ix, which will be 2.79 ampere. That one you have to prove that by finding the value of V1 and V2. V1 and V2, how you find? V1 and V2, you have to find using node analysis. This is the question. Question said using node analysis, you have to find the value of Ix, or you prove Ix equal to 2.79. So How many nodes here in this problem? Hey, please. You are in trouble. Nodes are
One note, sir.
5
Sir,
nodes there actually, right? If you
1,
go,
2, 3.
yeah, if you go to the real solution, you should tell me 5 nodes, because one node is here, another node is here, another node is here, another node is here, and the 5th node is here, which is ground reference node. So one, actually I'm just talking about, let's say this is 0 node. I'm going to tell instead of 1, I'm telling 0 node, 0, 1, 2, 3, 4. So 0 means it's a 5 node there. Why I said 0? Because this is B1 already given here. That's why I'm writing 0. So that B1, B2, B3, and this is V0. You can think V0. That's really fine. V0, B1, B2, B3, 4, 5 nodes, 4 nodes, 5 nodes, and they're like that. But I don't need to find the value of V3. I don't need it. Right?
Sir,
Because I need only V1 and V2. But you can find V3, no problem. And V0 also I don't need to find, but any children can answer, what is V0 equal to. Any of you can tell me what is V0?
100 volts, sir.
Absolutely good, excellent. This is
here is
actually 100 volt. 100 volt, because from here to here, you connect the voltmeter, you get 100 volt, right? Because this is the voltmeter voltage source, so it is giving you straight away 100 volt. So we are not worried about this point. And all what we can say, one thing here, at this point, okay, at this point, oops, at this point, the voltage is 100 volt, full stop. 100 voltage is 100 volt. At this point, the voltage is 100 volt. The node voltage here, there's a voltage source voltage 100 volt, full stop. Now, in this case, we can say that, okay, this is the node we can consider first. Let's say this is the current flow I1, this is I2, this is I3, which is IX we can consider as well, I4, this is I1, I2, I3, I4, just I'm assuming this is I5, and this is I6. Okay, and this is I7 is coming in, so you put in I7, then it's okay. I7, I6, I7, now that's okay, all those things okay. Now you can go ahead by one. How many KCL we can see altogether there will be, because this voltage already known, so you don't need to apply any KCL here, because this voltage is already known here at this point, so you don't need to worry about this node point. All what you need, because it's a known already. Now all unknown thing, one is KCL here, you have to apply. So if you apply KCL 1 here, what is the equation you should get?
I1,
I1 is in, I2 is out, I3 is out.
I3 out.
Okay, now what is the equation coming then? I1 is what? I1 is, hey, anybody can tell me I1 equal to what?
Yes, sir.
100
100 minus
Right,
V1.
beautiful. 100 minus V1 divided by 8. And what is I2? Minus I2. V1 divided by 4. Why are you late? Minus I3. I3 is what? What dark people are sleeping?
Sir, the screen cannot be seen.
Oh, screen cannot see. No, it can be seen. You
Sir,
cannot see. What? You cannot see.
you can zoom out the page.
What do you mean? Already.
We cannot.
Anyone? Are there any people
We
here?
cannot see the equations for KCL1.
Oh, okay. I got a point. What do you mean? I'm sorry. You should tell me that pull it up. Now you can see, right?
Yes, sir. Now it's okay.
Yes, sir.
There a little more.
Yeah, what's the problem?
If you could scroll up a little more, that would be better.
But I can see that it can see. I think you can see the full screen now.
Yes, sir.
Yeah.
Sir, now it's okay.
Now, how long up should be fine with you, Tanamnum?
Yes.
Mr.
okay now?
Zawata, yeah, it's okay, it's okay.
Oh,
Yeah.
Jawata. Okay, no problem. Now let's come here. V1 minus V2. Only you need to understand. This is important. Okay. Now let's come back to this point. This is equation number 1. You got it. Equation 1. Now equation 2 comes from here. KCl2. So if you go for KCl2 here, what will be the equation for KCl2? Let us see. How many currents involved? KCl2, a bit faster. How many currents?
4, sir. 4.
Now tell me, what is that? I3 minus I4.
I
And then I7 is what? Minus
Plus.
I5, I5 plus I7, right? I7 equal to 0. It's okay now?
yes, sir.
If all of you understand, then go for the I3. I3 equal to what? I3 equal to, already we have found I3 equal to V1 minus V2.
V1 minus V2 by
By what?
2.
I'm asking V1 minus V2 by
2.
2. Then I4 is what? Faster, I4?
V2 by 3.
Okay. And then I5?
So, V2 by minus
V2
V3
minus
by
V3
10.
by what?
10.
10. Good. And I7
8
is 8
plus 8.
equal to 0. All of you understand? This is equation number 2. This is how you have to write the equation 2. And then come back to the third KCl. Okay. This is the KCl. We are going to write now KCl.
In this case, we should find the V3 magnitude also.
Oh yes,
Yes.
because
We
why?
need V1,
Why?
V2.
Yeah, I understand. A good question. The reason why in equation number 2, you can see you need the value of V3, right?
Yes, sir.
You cannot, this equation 1 and 2, you cannot find the solution because in equation 1 and 2, how many unknown?
3.
3 unknown. Can you solve this 3 unknown from 2 equation?
No, sir.
That's why you need to go for the third equation. You understand now?
Yes.
Go. Okay, now first, what is the equation coming here? In that case, it will be, come on, how many currents? Duck. How many currents? Anybody? How many current? Only
3.
his
3.
3 current, yeah. I5 is coming in. Then next, I6.
I7 and I6 are going.
I7 is going, I6
Output.
also going, okay. Equal to 0, right? You okay?
Yes, sir.
Okay, now you come with this. What is the thing coming then? I5 is what?
V2 minus V3 by 10.
I5 is V2 minus V3, right? V2 minus V3 by 10. 10 minus I7 is 8, right? I7
8,
is
yes,
minus
sir.
8. Okay, minus 8. And then I6 is what?
V3 by 5.
Right, V3 by 5 equal to 0. This is another equation, the third equation. So now these are the 3 equations you have to solve, and then you find 2 values. Only the 2 values are V1 and V2.
V2.
And V1 and V2 value, once you find, then you substitute here. If you find
And divide
V3 also, if you find V3 also, no problem. You waste time, but no additional marks. Yes, one wanted to ask me some question. Any question?
So then we find the magnitude and we divide by 2 and we got the
2.79 ampere.
Yes. Okay.
If you get 2.79 ampere, your answer is correct. The V1 and V2 you calculate and substitute where? Substitute here. You got my point?
In the IX
yeah,
equation.
in the IX equation, right. This is the V1 and this is V2. You have to substitute these 2 value here. And you will get the answer equal to what? You get the answer 2.79, which is this gut. You understand it? Hey,
Yes,
what
sir.
happened?
Yes, sir. Yes, sir. Yes,
Good.
sir.
That's done. Now that's all about these things, and I'm going to show you. You will just try to solve the problem at home. The homework I have given already. You have to find the solution to this problem. This one you have to solve by yourself, and the answer is given here. If you have any problem, you must let me know, and we'll all of you discuss among yourself. You got the answer or not? If no, then we'll sit together and in another session. And another question after that, another question on this one, you can see over here, over this one is another question, and this question you have to find solution. Also the answer is given there. After finding the solution, you have to check the answer here. These two problems are there for you to solve by yourself, and the other practice problem you have to solve are, one is this, there are some question here, you can see these questions are one part is mash, this one is mash, and this one is node. So you solve the node part. This is a node part. Node analysis is done, so you have to solve the node analysis part by yourself. And then another question, practice problem
From the book. Sir, from the book.
no, you just follow this two pages. Actually the pages I have uploaded here, you can just from
They're
here.
on
No need to,
BOX.
yeah, no need to search from anything. This is from I'm sorry, you can find it in the BOX. You never visited the BOX, that's the thing. You check the BOX, and BOX are all given there. Now look at this problem. This is the problem. In this problem sheet, the first 5 problems are mash analysis. Don't do it. Oh, sorry. Cancel up. Okay, I'm going to go for the next one. Okay, now this is the mesh. This one, mesh. After the 5th one onward, this one onward, this is the node analysis. Start from here, and the answer is also given. So you can find the solution V1, V2, V3, and check the answer with this. You're okay. You're okay. Not okay. Just let me know. Then next class we can see the solution, how to find it. That's one thing. Then
Sir?
yeah.
Sir, I'm sorry for interrupting, but I have a class now, so I have to
Yes,
leave.
sir. Yes, sir. Please. Those who are having class, you can just go, and the video lecture it will be uploaded. You can see the video. Should be fine, no problem. If you have any question, you can tell me. Yeah, you have any question? Do you have any question?
I wanted to ask you about the quiz that we took last class. When can we get the solution for the quiz? Or is there any
the quiz you as the quiz question answer you are talking about?
Yes, sir.
Yeah, after marking the script, I'll give it to you. You can see the thing there. And at that time, the quiz answer script will be given. You better concentrate on today what I taught you and what are the practice problems you have to solve. Concentrate here. And that the class test 1 question will be discussed in the next class after finishing the marking. That time we'll discuss it. No problem. Thank you very much, Jawata.
Thank you, sir.
Okay.
Bye-bye, sir.
Thank you very much. Bye-bye. Now let's come back to the point. Those who are here, you can just look at it. These are the questions. All the things are given along with the answer. So you please check all the question by yourself and see whether you can find the solution or not. And the supernode problem, this one actually I could not finish it today. Next class we will do the supernode thing, and then we will start solving. So don't solve this problem. I'm just showing you here today. You don't need to solve the problem, the supernode problem 1, 2. This problem you cannot solve it, and don't waste time also for this. And next class when I this is another page actually, where this is another page you can see. Okay, this one another page. This is supernode problem. So these problems you can solve after next class when I will show you the supernode for the beginning. Then you can understand how to solve this supernode problem. So you don't need to waste time for that. So I think in the BUX, look at it. In the BUX, you can see all these things. Can you see supernode page 2, supernode practice problems, homework, lectures? Can you see these things?
Yes, sir. We can see.
Yeah.
Yes, sir.
All
Yes,
these things, all these things are already uploaded in the BUX. So you please download those things and start working. And only if you cannot solve the problems, then you can discuss with me. And you remember the supernode 2 page, you cannot solve it now. It should be possible after the next class. So other than that, all the other node problem you can solve. And in this practice problem, you remember the mesh and node problems are mixed together. Avoid the mesh problem, solve the node problem. And after following next class, when we'll finish the mesh analysis. After that, the mesh problem you have to solve. That's the way we are going to do. And next class, lecture 8, will be on mesh analysis. After supernode, we'll go straight away to the mesh analysis. And mesh analysis lecture 8 is also the slide I'm talking about. Lecture slide is also uploaded in the BUX. Please download that one also and go through the lecture notes so that at least you can understand something. And next class we can start with the mesh. You'll understand much better. And ask your friends to attend the class, otherwise they will be loser. And I will note it down all these things. Those who are present, definitely those who are present, they will get some positive, they will get some benefit, no doubt. They will be advantageous, there's no doubt. So all of you, please try to join the class. I appreciate if you join the class. We are trying our best, and if you one side, you know, I am trying from my side, you are not trying. One hand cannot make clap. So clapping, you need both hands. So your side need to be participate in the class so that it will be interactive and you'll understand much better. And question immediately you have to ask, that will be the better way to go. And any additional class required for solving the problem as a consultation time, I can propose that. I can manage that one. But all I need, some of you combine together, tell me that you have some problems, and then note it down, and then we'll you know, go for that schedule, consultation schedule, and then we can solve our problem over there. Okay. And next class I'll announce something like how the assessment process will be done during this semester. Final exam, midterm exam, you know that what about them, and how the weightage of marks for the class test, assignment, all these things will be discussed. Thank you. Okay, I think that should be fine. I don't have to do anything. The class time is over and our time is also over. Anybody got any question? You can please tell me, otherwise I'm closing. Yep, go ahead.
Yes, sir. I have a question, sir.
Please.
Sir, in node analysis, if we correct the equation, but somehow we cannot find the real value of B1 and B2, so will you give us a handsome mark or you cut down marks, sir?
That's a very good question. What he asked is Emon Chaudhary, right?
Yes, sir. Yes, sir.
Yeah, Emon. Everybody, I hope that understood what Emon said. Your equation is correct, but your answer is wrong. That is what Emon wanted to say, because calculation gives you the wrong answer. If this is the scenario, absolutely you get very handsome marks, no doubt. But Emon,
yes, sir.
Hey, Emon left. Okay, Emon. But if your answer is correct, but your equation is wrong, if it's the other way around, then negative marks.
Oh, yes,
that means somehow you yeah, copied the things. Okay, I think definitely you should get handsome marks. Any other question? No? Okay, Akib, do you have any question, Akib Hassan? No. Okay, fine. Jihad, no?
No, sir, I don't
Okay,
have
fine.
any question.
Borhanuddin, no? Okay. Muntasir?
No, sir, I have no
Okay,
question.
good. Thank you very much. Sajjad?
Sir.
Yes. Go ahead. Those who class or want to drop, you can drop. Yep. Go ahead.
Sir, we have an assignment which our last date on 13 July, right, sir?
Yes, sir. First assignment, assignment 1.
Yes, sir. And sir, the assignment, you said that the sum of your ID card number and divided by 3, and then
Yeah. For the
I
parameters.
didn't get that point. Sir. I didn't understand.
Okay. In that case, I can ask you. You send an email to me, and then I will ask you to contact one guy, and he can explain to you about these things. It is very simple thing. Your ID number is, you have an ID number, right?
Yes, sir.
So what is the third digit of your ID number? You know that?
Yes, sir.
Is it 0?
No, sir.
If it is a real number, then you have to divide, and from that process, you have to find out the value of the resistor, capacitor, voltage source. That's the way actually you have to do.
Okay, sir.
Okay, you send an email to me that where's I'll find a solution for you, because this is very much clearly understood from the assignment. I'm just asking, any other people got also the same problem?
Sir, the assignment in box, it's gone now. Where can I find it, sir?
Assignment gone from the box.
There was a Yeah, sir. There was a link for assignment in Bucks, but I cannot find it now.
Are you sure?
Yes, sir.
Just hold on a second. All of you agree with him, or it is not? Is it fact what he said? Okay.
Sir, I actually downloaded the page.
Okay. I'm
Yes,
just
sir. I
going
downloaded
to.
it before, sir.
Or before. I'll check it again, and if it is not there, I'll upload it again. No problem. Thank you very much for your information. If you see something like that, can you please send me by email the information? Sir, we cannot find it into the box. Can you please do it?
Yes, sir.
Okay, not only this, anything, please, next time. That is, thank you very much to raise this question. I thought it's already there. And now I understand that I have to recheck. But I'm requesting you, you please also inform me immediately by email that, sir, in the box, this is not found. Please let me know about these things also. Thank you very much for this information. Okay, I think that should be fine because I have another class after that. So I think we'll meet in the next class. I ask your friends to join the class. I will appreciate. Thank you very much.
Thank you, sir.
All right. Thank you.